and
240.
yeah. You'll notice that there's two values, because what you'll figure out, and you'll get more in depth next year, is that these values are cyclic, okay? They cycle around and they repeat each other. Eventually, and then like I said, you'll see this next year, when we talk about the sine graph, we put this in the x and y coordinate plane. The sine graph is periodic, and it keeps going like this. Have you guys seen this in, like, you guys take physics yet or not?
No.
Well, you'll see this in physics too. You'll see a lot of this trig stuff in physics. It's a sine wave, and it keeps going back and forth, back and forth. So this square root of 3 over 2, it hits here and here. Here and here, positive, but then negative, it hits here and here. And then once you go around the circle again, it starts repeating. So you see those values multiple times. That's why we see it here and here. So 240 and 300. So theta equals 240 or 300 degrees. And that falls within the interval of 0 to 360.
So it should be like from 600 and 480.
What was that?
So could it be like 600 and 480?
If you kept going, yeah. But you wouldn't technically list that. What you would list it at, you would do something like 240 plus 360n, where n is an integer. Because again, you have this circle and it keeps going around in those cycles. But that's if it's out of that range, 0 to 360. Now you also do that with radians. Find the exact values of the trig function at negative 3 pi. Well, you'll want to know where negative 3 pi is. Negative 3 pi is the same as saying what? Chris? Pardon? I didn't hear you. 180 degrees, okay? Or pi, right? Because remember, there's 2 pi in one full rotation. So this is 2 pi, negative 2 pi if I'm going this way. And I go another negative pi. So that coordinate point is right there, which is positive pi or positive 180. What's the coordinate point? Jack? Negative 1, 0. And if it wants the exact trig values of that, we know that sine of negative 3 pi is what? 0. Cosine of negative 3 pi is? Negative 1. What's tangent going to be? What is it?
0.
Right? It's going to be 0. Because it's 0 over negative 1. Remember, y over x. And then what's cosecant going to be?
Undefined.
Good. Undefined. Secant will be what?
-1.
Negative 1. And cotangent will be?
Undefined.
Okay, calculators out.
Dang it.
I think this is the last one we'll talk about today. Maybe not. Pretty much. Okay. It says find the calculator approximation of the following. Sine of 3.42. Is this in radians or degrees? Does this look like radians or degrees, Jack? This is in radians, okay? So let's make a note here. This is in radians. Your calculator has two different modes. It has radians and it has degrees. So you need to go to your calculator, pick mode, and you see the option for radians and degrees?
Yeah.
Make sure it's selected in radians because that's what we're working on.
Okay. Where is the mode?
Mode.
Mode.
Negative 0.27, 48, 246, 703.
Okay, so you guys are radians?
Yeah.
Okay, all you have to do when you're evaluating something like this is now go to your main screen, hit sine, 3.42. You don't have radians?
Go to mode.
You hit mode.
it's not clear.
Alright, for the rest of you, hit sine, 3.42, hit enter.
Negative 0.27482467003. 300.
Because you're like in. You're actually.
Yes.
Let me take a selfie.
Is it the third one down, guys? Is it the first or the second? Radians first? Alright. I'll have to fix it later. Okay. So when you put in sine 3.42, what do you get?
Negative 0.27.
Negative point.
275. Just do that.
Okay.
Say dig, everybody.
Okay. So the approximation is negative 0.275. Now let's talk about secant real quick. You'll notice that secant is not on your calculator, right? You only see sine, cosine, tangent, Nick.
You put it over 1.
So you put it over 1.
Under 1.
Well, under 1. Because we know that secant theta is the same as what? It's not the same as cosine, it's what? Reciprocal. So it's 1 over cosine theta. So what you can do in your calculators now is just do 1 divided by
1.285. That's what I got right.
and what do you guys get?
1.285.
1.2851.
Okay.
We don't like the 1.
No, it's 1.
Respect it for what it is.
Okay, now real quickly, and I want you to go back to mode, and I want you to put it in degrees. No, I don't. Not yet.
Oh,
I lied. Not yet. Okay.
Just one dinner.
Yes.
So, if you have it in radians, does that do like if you want to just like put like a 3 plus 2 and it's in radians, that can like change it?
No, it will only change it when you're working with the trig functions. All other operations will stay the same. Next.
What you have on some sort of financial relationship about
Say it again.
like what you have where it's secant and where you cosine is not.
What do you mean it's not the same?
You have 5.6041 on the top and 5.69.
Oh, I wrote them.
So you get a different one.
Thank you. Okay.
It's 0.89.
All right. Now let's take a look at this. Find the values. Now think back to number 1, okay? What we had to do in number 1 is we were trying to find the angle, right? At what angle would sine be 0.3210, correct? That's what we were trying to do. Is there a 0.3210 in the x or in the y values? Because that's where sine is, right? Is there a 0.3210? Where?
Why?
Where in the y?
Above the line.
Do you see it in your unit circle?
No.
It's not in your unit circle. Because in your unit circle, we have halves square root of 2 over 2 and square root of 3 over 2, right? On these sides for zeros and ones. So, again, do you see 0.3210 in your y values? So, is angle S a common angle? No, it's not. This is where you're going to use your calculator again. And we kind of talked about this a little bit when we were back in the geometry book and we were finding the angles. I can divide basically by sign, and do you guys remember what dividing by sign really is? It's the what? That -1, that's called the what? What is it called? Arc sign. So you can do the arc sign, but notice the interval. We want the interval to be in what? Radians. So you should already be in radians. So right now, hit your arc sign. Remember that's second sign, 0.3210.
0.3267851765.
Okay, Stephen, can you say it again but slower?
0.3267851765.
Okay. So the angle is 0.3268 radians, or approximately 0.3268 radians. Now, let's look at the next one. The next one, this should be 6. The next one says, find the exact value of S in the interval 3 pi over 2 to 2 pi. What quadrant is that in? 3 pi over 2 and 2 pi, what quadrant?
Third quadrant.
No, what quadrant? Tyler?
Third quadrant.
What quadrant? The fourth quadrant. Remember, guys, it's a full 2 pi to get all the way around, right?
But isn't it?
Yes, it's true. Yes.
Isn't it 1?
There, that's pi. This is 3 pi over 2. You start with 1, 2, 3, 4.
I thought it was the other way around.
What do you mean it's the other way around? Okay. So it's in the what quadrant? Fourth quadrant. Now, if we look at what it evaluates to, it evaluates to negative square root of 3 over 3. Is that a special
No.
angle?
No.
It
It will be. Because what's tangent?
Dang it.
Y over x. So, now this might take a little bit more thinking on our part. So we're looking, so let's go back here. Now, the nice thing is we're limiting it to this fourth quadrant right here. And what I want is negative square root of 3 over 3, where it's y over x. Now, let's think about it. Could it be 315, square root of 2 over 2? No. Okay. So, and we know it's probably not going to be 360. It's probably not going to be 270, right? Because those aren't kilos, zeros, and ones. So now we got to think about 330 or 300.
300.
300?
330.
So if I put 300, wait, what one did you say?
I was just kind of being positive.
Okay. If we did 330, I don't even know what ones you guys said.
300. 330.
Okay. If I did 330, I would do y over x, and that's actually negative. And then if I reduce this, the 2's cancel out, and I'm left with negative 1 over square root of 3. And then I'll need to rationalize it. And it's what? Negative square root of 3 over 3. So I go back to this now, and I know that the angle S
Okay.
will be tangent at 330 degrees. But I want it to be in radians.
Convert.
So we're going to convert.
Well, we want this.
What is it? Pi over 6.
How? Dang it.
Okay. So there's one other thing I want to quickly talk about, and it's not on here. Let's talk about sine theta equals, let's just say 1/2. Okay? Sine theta equals 1/2. What should it be?
30 degrees.
What should it be?
30 degrees.
30 degrees or 150 degrees, right? Okay. If I have sine of theta equals 1, we know that theta should equal what? 90 degrees. Okay. What if I say now though, sine theta equals 3/2? Is it is this on the unit circle? Let's start there. Yes or no?
If it's in radians, it is.
No, not even in radians. Well, okay. I take it back. It's not on the unit circle, is it? Okay. What I want you to do right now, remember this is when we were talking about, well, we'll use our calculators, right? So take your calculators and switch it back into degrees real quick. So do theta equals arc sine.
Where's the theta sign?
I'm sorry, you don't need to do theta. You just need to do arc sine of 3/2. What does it say?
Error.
Okay. Try it in radians. Go to radians, try arc sine 3/2.
What'd you say? Failure like that.
Error.
Error. Okay.
Could we try 1.5?
Try 1.5. Would it make a difference?
You'll know.
No? Okay. Let's go back to this unit circle and just watch up here for a second. Okay. So let's look at the sine values. Here's 0. Jack?
You do 1 divided by
Sine. But yeah, but that we're not doing 1 divided by 6. Okay, but look at sine values. We start at 0. It goes to half. It's a difference. It's sine. Do sine. Not sin.
Sit up.
Miss Piper, Miss Morell will be like, why did you teach them sin? Alright.
I'm gonna sit.
Square.
Oh!
What's square root of 2 over 2? Somebody quickly in their calculators. Give me a 10th approximation, 0.7, right?
How do you do this?
0.7 over.
Okay, it's about 0.7. So then it's about 0.7. What is square root of 3 over 2 approximately? Is it 0.8? 0.87? Okay. Let's just say if I did, let's do 80 degrees. So do sine of 80 degrees, tell me what you get.
This was sine 80.
Yes, so sine of 80 degrees, what do you get? Is
Is
it in degrees or radians?
Radians. You want that degrees?
I want degrees.
On it, I need.
0.98? Okay. And then when we get to 90 degrees, it's 1, right? And then when I go back around, 120, I'm going around this circle, 120 is 0.87, and then it goes back down to 0.7, and so think about these values. I start out at 0 right here, and then I go to half, and then I go to 0.7, 0.8, 0.9, and then I go to 1. But when I get to 1, what starts happening? It starts back down. And then it goes to the negatives, but then when you get back up here to 0, you already have gone around the circle once, and so guess what starts happening? It starts repeating again. Will you ever have a sign value higher than 1? No. I would write that down. You will never have a sign value higher than 1 or lower than what? Negative 1. So the range is from negative 1 to 1. What can you say about cosine? Same thing. Cosine, your range will be from negative 1 to 1. So if you ever get a problem where it says use your calculator or tell me the value of cosine theta at where it equals 5, what would you say? It doesn't exist. It doesn't exist because it's greater than 1. Nick?
Does that apply to secant?
Not quite. Because with secant and cosecant, it's 1 over like a fraction. So, and those graphs actually go up. So they're in. So actually, it doesn't exist from 1 to negative 1, but exists above 1 and below 1 because they're parabolas actually. So, all right. Do you guys know how to find an angle? Do you know how to find an angle using your calculator? Alright, probably.
What about for tangent?
Tangent is something a little bit special. It is special. Because tangent is y over x. The graph, and you're not going to need to know the graphs for this, but the graphs actually, they're asymptotes that will look like this. So that because do you guys remember when you did some of the y's over x's, they were undefined? You know, because if you take if you go up here and if you take 1 over 0, that's undefined, right? So at 90 degrees, tangent would be undefined. So there's an asymptote there. It would never actually exist at 90 degrees, but it approaches it. And then same with 270 degrees. It approaches it, but never exists. Probably.
How do you find the angle with your calculator?
Okay, how do you find the angle with your calculator? Well, let's go back to example number 1. Technically, I should be able to do this problem using the unit circle. But I can also use it with a calculator. Because I'm going to divide by sine, so theta would equal arc sine. And I would put negative square root of 3 over 2. And it should give you the degree. Now, the only problem with this is that your calculator will only give you one of the values. It won't give you both of them. But you should be able to figure it out, right? All right, questions? Jackie, can you go? Okay.
That's actually just.
We need a shout out.
Shout out here.
We're good?
Hey! We're good.
Okay, do you have any time left or not?
Yeah.
Like 20 minutes.